Now we're going to continue working on that same data set. And the first thing we're going to do is talk about the measure of skewness. And let me give you a little bit of background on this. In statistics, the bell curve, the normal curve, which we'll talk about in great detail later, is sort of like the gold standard. Okay? So ideally our data will look something like that. Well, most of the time it doesn't. Sometimes it has the bump on the left. Now when it has the bump on the left, we say that it is right skewed. It's actually the opposite. When we have the bump on the right, we say that it is left skewed. And the formula that we will use is skewness is equal to 3 times x bar minus x median over S. Now, if you're using Excel to do your work, their formula is slightly different, so don't use that when you're practicing and getting ready for the test. So let's consider this particular problem. We saw in the previous movie that the median was 805, and we were given x bar of 992.9, and we were given S of 408.6. So let's go ahead and put this all together. So our measure of skewness is going to be 3 times 992.9 minus 805. And that's going to be all over 408.6. So that's going to be 3 times the quantity. Wait, where'd my sheet go? 187.9. Hang on a minute. There. All over 408.6, which will be 563.7 over 408.6, and that's going to give me 1.38. Okay, so this is going to be right skewed or positively skewed. Okay, because the measure of skewness is positive. So that means if we were to draw this data out, it would have the bump to the left. Okay, now don't worry about drawing things out or looking at drawings, but that's just what's going on underneath. Now, a word to live by, skewness runs between -3 and +3. So if you have a value that's either considerably larger than 3 or considerably less than -3, you need to take a look at what you have done. Okay. So the next thing we have is the z-score, and that's x minus x bar over S. So this is actually a pretty straightforward formula. The x is just the number value in the question. So in this particular case, x is 574. You subtract out the x bar, which you are given. So that's 992.9. All over S of 408.6. And that's going to give me minus 418.9 all over 408.6. And when you work everything out, you get minus 1.025, and I just rounded it to minus 1.03. All right, pretty straightforward. Then finally we want to look at some intervals, and let me make a quick diversion here. There's something called the empirical rule. My pen is being hostile today. And what the empirical rule says, if I have a data set that follows the bell curve, essentially when I have x bar plus or minus 1s, when I have that interval, about 68% of the data falls in there. Okay, still if I have my data set that follows the normal curve, the bell curve, if I take the interval x bar plus or minus 2s, then about 95.4% of the data falls in there. And x bar plus or minus 3s, that's going to be about 99.97% of the data falls in there. Okay, now that's a guideline. We don't necessarily have to go by that, but it gives you an idea. If this is true, if you set up these intervals and they are true, then the data set essentially will follow the bell curve or the normal curve. All right, let's look at our example here. So we have x bar plus or minus 2s. So that's going to be 992.9 plus or minus 2 times 408.6, or 992.9 plus or minus 817.2. And to set up my interval, I have a lower value and an upper value. So I'm going to have 992.9 minus 817.2. Did I say 992.9? Okay. Anyhow, minus 817.2. And that's going to give me 175.7. Similarly, I will have 992.9 plus 817.2. And when I add those up, I get 1810.1. So my interval runs between 175.7 and 1810.1. Okay, this is actually a two-part question. You set up the interval, and then you figure out how many of the data points fall in this interval. So the interval starts at 175.7. So our first data set is, our first data point is 568. So we'll start counting right at the beginning. We'll take the whole first row, the whole second row, the whole third row, and then take the 1578, 1569, 1629, 1679, and then we'll stop. So we will exclude 1869 and 1915. So we'll say that 33 of the 35 points fall in the data set, fall in the interval. That gives me about 0.94 or 94%.